In this second in the series of short videos, I'm going to explain how to calculate body weight and to calculate the onset of movement in the counter movement jump. So the first thing I'm going to do is just put in the words body weight in newtons in cell A3. And so just to explain before I go any further, we tend to take body weight calculations over a 1 second weighing duration, because people might sample at different sample frequencies and for different durations. What I'm going to do is going to put in a calculation here that will take into consideration the sample frequency that's been used to collect that particular data. And then if this is updated, then the subsequent calculation of body weight will also be updated. So the way we do that is, first of all, we are taking the average body weight, so the mean over the first 1 second of data collection. So I'm just going to put equals average to begin with. And then I'm going to use the index function, and by indexing we'll be able to take a particular reference point where we want the weighing period to start and to stop. And so first of all, after we've written the word index, open a bracket, and we're going to use the frame numbers in a moment. But first of all, what we're going to do is highlight the column of data in which our force data is currently situated. So for this example, it's in column G and through cells G3 to G5002. And then I'm just going to put in a comma, and to signify the frame number at which we want our weighing duration to start, or our weighing period to start, I should say, we're just going to select the number 1 here, so frame number 1, because this subject's staying nice and still from the onset of data collection. And then we can close that bracket, put in a semicolon, type the word index again, and this time open brackets, select the same force data again. You can either do what I've done, which is just press Control Shift and down to select that entire force data time series, or you can just copy and paste this across or type it in, whatever you'd like. Now to put in the end point, what we want is the first 1000 frames represents the first 1 second of data collection, because we're sampling at 1000 frames per second. So if we simply just select cell B2, which contains that 1000, what this formula is then going to do is give us the average of that force data between cells E3, which for us represents the start of data collection, and 1000 frames in. And so now I just have to put in a second bracket just to close off this formula and press enter, and it's going to give us an estimation of the subject's body weight equal to, in this example, 753 newtons. And just to reiterate, if we were to change our sample frequency, or somebody that's using this spreadsheet collected their data at a different sample frequency, whatever we change this to, so if we half the sample frequency to 500, this formula will automatically update, just like the time interval between each cell, to equal now a 500 Hz sample frequency. So in other words, it will take subject body weight as the average force over the first 500 frames, as opposed to, in this example, the first 1000 frames. The next thing I'm going to do is to calculate the standard deviation of that same weighing duration and multiply it by 5. So I'm going to call this 5SD, SD for standard deviation of body weight. And the reason is that we use that 5 standard deviations of body weight as a force threshold to determine the onset of movement, which is the second part that we're going to cover in this tutorial. So what we can do is, for the sake of ease, is if I just click back on the cell just above where we just calculated body weight, if I just copy inside the information inside that cell and just paste it below, I can change average to STDEV, which will give me, at the moment, if I just press enter, just the standard deviation over that first 1000 frames over which we calculated body weight. But we're interested in multiplying that standard deviation by 5. And so if I just place a bracket just in front of the S for STDEV and another one at the end of the formula, and then put in asterisk 5, so multiply by 5, that's going to give us a value equal to 5 times the standard deviation. So in this example, we've got 16 newtons. And so from this, we can work out our onset of movement threshold. So if I put just onset threshold for simplicity, which again is going to be in newtons, all we're going to do is equals the body weight value that we've got 2 cells above, minus this 5 standard deviations of body weight just below. And so this tells us that the very first instant along this force time trace from the initial period that force drops below 737 newtons, that denotes the onset of movement, and that will occur around about it looks about 1.8 seconds into the movement, but we'll see as we progress through this tutorial. And so we can begin to identify some instants that we're interested in as practitioners or researchers. And as part of those instants, we're going to take frame numbers and we're going to take the associated time in seconds at which these instants occur. And the reasons for that will become clear as we progress through these tutorials. So the first instant that we're interested in discovering is the onset of movement. Okay, so to do that, we're going to use the match function. So if I put in equals match, open a bracket, and we're going to try and match this value, so 737 newtons, which represents our onset threshold, and the last data point before force drops below 737 newtons from the beginning of this force data collection period to the end. And so what we do is put in after we've selected our force time series as we did before, we're going to put in a comma, and then we're going to put in a -1 to give us the very last value that is greater than 737 newtons from the beginning of data collection. So if I close off this bracket and press enter, scroll up a bit, it's saying that the very first point at which, from the beginning at which that force data drops below 737 newtons is 1,715 frames in. So around about here somewhere where it represents that initial fall in force production. But according to the work by Owen et al., we're meant to backtrack 30 milliseconds from this time period because the athlete will have actually started moving by that point. And so we're just going to add something to this formula. But before we do, we're just going to close this initial formula that we've already inputted in a set of brackets. And then what we're going to do, we're going to subtract or backtrack 30 milliseconds. And we're going to do what we've done in previous examples, and we're going to actually make sure that that 30 milliseconds is automatically updated if you end up changing your sample frequency, or if indeed somebody else that's making use of this spreadsheet is using a different sample frequency to 1000 Hertz. And so next what we're going to put in is 0.03. And then we're going to divide that by 1 divided by the sample frequency. And like we've done in previous examples, we're just going to look that sample frequency cell location in just by including $signs around the letter associated with that cell number. And then I'm just going to close this formula off with a couple of brackets and then hit the enter key. And so all that's done, you'll notice, is that the original frame number that associated with when just before this force was going to drop below 737 newtons from the start point, it was 1,715 frames in. So all we've done is taken 30 frames back, because 30 frames in our example represents 30 milliseconds because we're sampling at 1000 Hertz. And so now it's identifying the frame number that's associated with the onset of movement. So just around about this point here is 1,685 frames in from the onset of data collection. And now, even though it's quite simple to work out what time into the movement 1,685 frames represents for this example, because we're sampling at 1000 Hertz, we're going to put a formula in nevertheless, just to give us a timestamp, and we're going to do that based on the index formula. So like we've done before, we're going to use index, open a bracket. This time we're going to select all the data in which our time periods are, put in a comma, and then our reference point is going to be that frame number we just established, 1685. Close bracket and enter. And what that does, it gives us the time, or the associated time, that represents frame 1685 in our example. And now, because it's not always that easy to work out from the curve where that point occurs visually, so that point of onset of movement occurs visually on this graph, what I like to do is just add a vertical line that will drop in automatically through the force point at which onset of movement is said to occur. And so I'll just move the graph down slightly, and I'm going to put in a force value that's very unlikely to be achieved of 10,000, and then 0. And the reasons for this will become clear in a minute. They're essentially just our 2 points to stipulate our vertical line that we're going to put through in a moment. What I'm going to do is right click on the chart, click on select data, and I'm going to add an onset. Let's just call it onset. I'm just going to add an onset value to this particular chart. And so our X values are going to be our time values that we just established. And if I press Control, we can select time twice. And then I'm going to click on the Y values and select 0 and 1000. Again, this is now giving us at time 1.684 seconds, we've got a value equivalent to 0 newtons. And again, at time 1.684 seconds, we've got a value equivalent to 10,000 newtons. Okay, and I'm going to press OK. And what that does, it gives us, because we've still got the same type of chart, so it's a scatter plot with smooth lines, it gives us a vertical line that crosses the force data point at which onset of movement is said to occur, or in other words, the time that's equal to 1.684 seconds. But now it's rescaled this graph automatically, which we don't want. So if I put that back, if I just format axis, put that back to, I think it was 3,500. There we go. What that now does, if we just hide those numbers that we actually don't need, it's just to give us a nice visual representation of when onset movement occurs. If I just put that graph back over the top to cover those, what we've got is a vertical line which represents onset of movement that passes through the point at which this has been identified over here. And so that's useful, especially if you're processing large sets of data, so you're doing quite a lot of analyses in say one sitting. It's just another one of those easy visual cues to give you fair confidence that onset of movement is being identified at the right place. Obviously, if this vertical line representing onset of movement was to occur somewhere in the middle of the wane phase, or even more ridiculously, somewhere after they've completed the jump, then you know something's gone wrong. So I like these visual representations of where data points are said to occur, or in other words, instants are said to occur, just to help me be confident with the data that I'm processing. Okay, so that's the end of this tutorial. You'll find a link to the spreadsheet as it currently looks at the bottom of the video under the description. So yeah, hopefully you found it useful, and I'll be back soon with part 3 to discuss further processing and next steps.